This video is to demonstrate the procedure for estimating a steep slope project, be it shingles or metal roofing, using OneView Plus. We have the typical scope and specification section that is completed very simply and quickly once those specifications and project requirements are determined. Selections are made from the drop-down box as it is in low slope roofing. The deck type is important to know, particularly if there is nail board involved. The big distinction between low slope and the steep slope is the pitch, which OneView Plus, and especially in conjunction with PlanSwift, can automatically calculate. The pitch here in this line needs to be completed in order to determine the labor involved. The quantity of materials needed to accommodate the pitch is taken into consideration during the digital takeoff and area calculations, particularly with non-residential new construction. Nail-based insulation or nail board is involved, and the determination of what's required is either the R value specified or a thickness. If we call for an R value of 30, and of course it's vented nail board because it's a shingle job, with a 5/8 OSB facer and 20 PSI, the system automatically provides for a 5-inch vented nail board, which has an R value of 20.5. But to meet the R30, we do need another layer of ISO underneath that, needing another 9.5 R value, which we can achieve with a 1 3/4 inch thickness, which gets us to the required R30. If you want to change the ratio of the thicknesses to nail board and the insulation, you can just simply manually change from the drop-down box what you want to use for the nail board thickness, and that automatically will change the thickness and R value of the layer of ISO. The drip edge and fascia scope are just yes or no answers that does provide further information further down in the estimate. For the soffit depth at the eave and the rakes, you need to select the typical soffit depth based on the overall length of the panels available. For example, a 12-inch eave soffit and a 6-inch rake soffit. The valley type is relevant because if it's metal, it needs to pick up the metal, and if not, it needs to pick up ice and water shield in the valleys. Going to use GAF as a listed manufacturer, and that's what we'll use for the products involved. To go back to the scope questions, what we completed was for area number 1, and area number 2 or 3 could be different. The pitch could be different, whether there's nail board or not could be different, and that gets reflected when we fill in a number of squares for a subsequent roof area. Everything defaults to the same as roof area number 1, but can be changed manually to meet the requirements if that respective roof area has a different configuration. Before we get to the digital takeoff of the number of squares, I want to point out what the scope and specification answers have provided in terms of information at this point. We have no substrate board, no vapor barrier. We do have the 1 3/4 ISO 4x8s, the 5-inch cool vent with a 5/8 OSB facer, and 8-inch nailboard fasteners designed for a wood deck. GAF Weather Watch and the 15-pound asphalt felt, which can be changed to the synthetic felt, deck armor, or whatever as desired. We changed the underlayment to deck armor. The unit price will change accordingly. We have the GAF starters and the Timberline HD, which can be changed manually using a drop-down box to select a wide variety of shingles from the database, or if there is a specific synthetic slate or some other type of shingle that's not in the database, that can be entered manually. To calculate the number of squares and accommodate for the pitch, we need to do so using the area drop-down box in this menu bar in PlanSwift, if you're using PlanSwift. If not, you can enter it manually. So we're doing a shingle roof, and that calculation we want to be in number of squares. And we've already said the pitch is 612, so we can do the digital takeoff. And go to the Send Data tab, where you can see the differences between the flat takeoff and the slope takeoff. So we have 3157 or 32 square of shingles. The eaves do not involve slope, so we can just do the typical takeoff. For the eaves, now rakes, hips and valleys do involve slope. So for that, we need to use the linear takeoff for rakes, which also is a 612 slope. So we want to send that data for the rakes to the estimating sheet. A ridge, or in this case, it's really just a peak. We have no hips or valleys in this particular roof area, but if we did, we would use the hip drop-down box under lineal. And I wanted to point out that there are two areas to involve for the pitch, because it's conceivable you could have one pitch on one side of the hip and a different pitch on the other side. And in that case, just indicate pitch number 1. Pitch number 2 defaults to the same, but if it were different, you can then change that to reflect the different slopes on the respective side of hips or valleys. So now what we have are the quantities of the insulation, the nail board screws, the ice and water shield, the felt underlayment, the starters and the shingles. Since the lineal feet of starters are less than a full bundle, it shows 0, but it rounds up to 1 in the total. The labor is 35 squares of walkable asphalt shingles with a slope less than 7/12. If that slope pitch were different, that labor would be reflected down here. And if it was a tear off, additional labor is added. And we have the respective lineal foot of drip edge and fascia, seal ridge shingles, eave soffit and rake soffit, and gutter. A metal roofing is on a separate tab, but the construction of the estimate is virtually the same, other than more typically don't have vented nail board. And the calculations for straight roof panels again comes from the area drop-down box for metal roof, which is calculated in square foot rather than squares.